Let's get to our desks quickly. Okay. Okay, so good morning, everyone. I said good morning, guys. Good morning, sir. There we go, I love it. Welcome to the guys that's signing in via live streaming. It's fantastic to have all of you guys here and ready today. Could I ask you guys that once you are seated, that we tune in mentally. I have promised 2 people chocolates, so I'm going to ask the lady to choose which one would she like. That one. And then you're getting that one. Woo! So I just want to say, if the 2 of you get a lot of friend requests after this, you know why it is. Okay? Okay, so ladies and gentlemen, welcome to our second last day of teaching. Today is going to be a bit of a mind stretch because I am going to make it my personal mission to try and catch you out. Yes. Okay, I am going to make like I'm an examiner, and I'm going to try and catch you guys out by asking you typical exam type questions specifically about trigonometry. So today we're going to focus the whole 2 hours on just doing trigonometry. Are you guys ready for this? No. Okay. I hope you guys are ready, because today we are not really going to work out of the book itself. We are going to look purely at previous year's exam papers. So, we are going to start, ladies and gents, with basic simplification using both grade 8 or grade 11 as well as grade 12 trigonometric identities. Now for this, you are going to have to know your reduction formulas, as well as how to handle things that's larger than 360 and negative, as well as co-functions, as well as your basic identities. Now, ladies and gents, for homework yesterday, I gave you guys, please go through your grade 11 work, the reduction and things, so that we can handle questions like these. Now, before we go too quickly in this, ladies and gents, I just want to pause this and say the following. There's 3 basic things that I'm going to tell you with any trigonometric sum that you want to do. Number 1, your first step is always get the angles between 0 and 360. If the angles are negative, you get them positive. If the angles are larger than 360, you subtract 360s until you get them between 0 and 360. That is always step 1. Step 2 is use reduction formulas or co-functions to get your angles between 0 and 90. So that's your second step. Get your angles between 0 and 90. Then your third step, ladies and gents, is now where the trick part comes in. It becomes a bit tricky because I'm going to say the following. I've got a rule of thumb. The rule of thumb is the following. Do not make your sum larger unless you've got no other choice. Okay? Always try and make your sum smaller unless you've got no other choice. Then you make it larger. Please, please, please remember that. I'm going to say it quite a few times to you today. Because what I have found in my experience, and those of you that's tuning in via the live streaming will also relate to this, a lot of you guys run into a trig sum, you try and do some fancy magic, and then halfway in the sum you have no cooking clue what you've been trying to do, but you know you are further away from the solution than you were at the beginning. And then what do you guys do? Skip to the next question. Okay? Or you try and manipulate that thing until you basically pass out, and you've got about a 3/4 of a page that you've done on a 3-mark question. So today we're going to work through that, but before we do that, I'm going to throw you into the deep end by asking you guys to simplify the following trigonometric expressions. So I am going to give you guys, let's make it 12 minutes to please simplify those two. And I want actual answers, because both of them can be simplified into actual answers. Ladies and gents, go for it. And again, for those of you that, listen to me carefully, guys, for those of you that are really good at trigonometry, okay? Now, some of you guys are going, oh, I wish I was that person. But for those of you that are really good at trigonometry, and you find the explanations a tad boring, and you are getting bored, please, there is enough exercises in this book. Okay, there's a lot of exercises to keep you busy with. But I do encourage you to pay attention on the board because it might just help you in other math sums. So let's start with the first one. If I look at cos squared 180 plus a times by tan of 360 plus a over cos of 2a plus 90, sorry. And this is times by tan of 315. My step one, again, understand the way I approach trigonometry. I go very systematically. I approach it, number one, get my angles between 0 and 360. So this one is too big, so all I do is subtract 360. So this, all the rest, I leave the same for now and just subtract 360, and my answer is tan of a. Okay? There we go, ladies and gentlemen. Now, next up, I ask myself, okay, but my angles are not between 0 and 90, so now I reduce them. So this one is simply in the third quadrant because of the 180 plus. And now I know there's quite a few of you that unfortunately did this. And if you did that, unfortunately, you lose your mark, sunshine. Oh, I'm talking to you. Guys, be careful. That square counts both for the negative as well as the cos. We will try and catch you guys out with that. I guarantee you guys. Now, tan of a is absolutely no worries at all. Now, the 2a plus 90. Again, some of you went and applied the cos compound angle identity. Please don't. Now you guys are going, but that was my only thing I did right. Guys, listen to me carefully. For those of you that struggle with co-functions, because this is a co-function, I'm just putting it out there. Remember, your co-function rules according to the cast diagram. Here I work with 90 minus, here I work with 90 plus, and there I work with minus 90. If you've never done it this way, it's now a good time to start. The 90 tells me cos changes into sine. Sine of 2a. But the plus 90 tells me I'm working in the second quadrant where cos is. That's how you get it in a short way. Okay? I want to quickly ask you guys this silly question. And I'm saying it's a silly question, but it's an interesting question because especially those of you that do AP maths, you know that you've got to do the co-functions of the inverse functions as well. And now you guys are going, okay? Ladies and gents, Let me make maths very simple for you. What is the cofunction of sine? If I look at cofunctions. What is the cofunction of sine? Someone quickly tell me. Cos, right? How did I get that? My teacher taught me, okay? Guys, between you and me, that is what the cos stands for. Cofunction of sine. So if I go from cos to sine, I just take the co away and I go to sine. So what is the cofunction of tan? Put a co in front of the tan and you get cot, cotan. Or if I go from cotan and I take the co away, I just go to tan. What about sec? Cosec. Okay, and from cosec I just take the co away and I get sec. Ladies and gents, that is where they get it from. Cofunction of tangent. Cot. The cofunction of sec. Cosec. So there I've just taught you university style maths and you hopefully can do it quickly. Okay? Now ladies and gents, let's quickly look at tan of 360. I'm going to quickly talk to the ladies because the gents are way too lazy to do this. Quite a few of you guys are going to write here tan of 360 minus 45. Please don't do that. Guys, just write it for yourself beneath the tan because we don't give you any marks for it, so you're wasting time. Now tan in the fourth quadrant is negative. Why am I writing in red? I don't know. Okay. Negative tan 45 degrees. I like to put my negatives in brackets so I don't forget there's a multiplication there. Now, ladies and gents, we're sitting with this thing where a negative squared is a positive, so this is cos squared A. But now, I can also, I'm getting sidetracked, I can calculate tan 45. Now, let me quickly just make it real for you guys. I know a lot of you guys love your calculator. I see that lady there, she's got a calculator next to the, you know. Ladies and gents, when you write your NBTs, you're not allowed a calculator. Now the second thing which is scarier than that, sir, in your first year at varsity calculus, you're not allowed to take a calculator into a semester test or an exam. So you have to get used to doing trig without a calculator. So you've got to know your triangles or your special angles. Now, ladies and gents, we need to get back to the sum and ask ourselves, how can we simplify? By expanding the tan into sine of A over cos of A. And if I look at this one, it's going to become negative 2 sine A cos A. Again, I expand because I have no other choice. So I'm going to, that one divides away with one of those. That one divides away with that one. That sine A divides away with that one. At the top, I'm left with 1. Minus times by minus is a positive 2. Okay. Where do you guys lose your marks? Signs and identities. In these kind of sums, it's by signs and identities. Let's look at the second one. Now, the second one was absolutely beautiful. Okay? So the second one, ladies and gents, I'm going to follow exactly the same procedure. First, get my angles between 0 and 360. So I'm going to add 360 there. It might be different than the way you did it, and there's forgiveness for that. Sine 330, tan 225. Again, ladies, don't now go and write step by step what you do. Write it on the top. This is in the fourth quadrant, so it's 360 minus 15. So it's positive cos 15. Sine 225 or 255 is in the third quadrant. So it's 180 plus 75. So it's negative sine 75 degrees over fourth quadrant. So it's negative sine 30 minus third quadrant. So it's positive tan 45 degrees. Now, some of you, I don't know whether any of you guys did it, it happened this morning in the Afrikaans class, expanded sine 30 to become like 2 sine 15 cos 15. If you didn't do that, praise the Lord. I'm happy about that. You didn't do it. Guys, this is a special angle. So I'm going to work this out using special angles. If you struggle with remembering your special angles, please come and talk to me. I'll gladly show you a trick or two about how I do it. Now, cos 15 is an issue because it's not a special angle, but please don't go and expand it. Don't do 45 minus 30 because there might be something else you could do first. Now what I would try and do in this case is try to get my angles the same, and this would give me cos of 15 degrees. So this minus and that minus divides away or becomes a positive, leaving me with cos squared 15 over a half, which is the same as 2 cos squared 15. Now, ladies and gents, doesn't that look familiar? That looks like a double angle identity. 2 cos squared theta minus 1 is the same as cos of 2 times theta. Well, that's 30. So my answer is root 3 over 2. I love it. Doesn't it feel amazing? It feels fantastic. Ladies and gents, just when you guys get comfortable, please go and do that one for me. Okay? I'm going to give you guys 10 minutes to do that one for me. I've got to be honest that I am quite impressed with you guys. Okay, I'm quite impressed with those that I've looked at. But I know that some of you guys are looking at this and going, no clue where to even start. Okay, ladies and gents, I fully understand that. So that's why I'm going to work through this example with you guys and again show you the tricks of the trade. Sorry, I'm just trying to get my board eraser here. I know I put it in somewhere. There we go. Okay. If I look at a sum like this, I always first ask myself, first of all, the sine 66, how does that relate to the 8 and the 16? And initially, it seems like no correlation between the two. So what I try to do is, okay, 66 is too big. So I try and see, can't I use co-functions? And in this case, the answer is yes. This is the same as cos of 24. Ooh. Cos of 24, now 8 and 16, that goes to 24. So I'm going to try and say, okay, I don't have any other choice except to expand. So this is going to give me cos of 8 degrees times by cos of 16 minus sine of 8 degrees sine of 16. Oh, but wait, that is P. And that is M. And there's your answer. Ah, sir, it can't be that easy. It is. I promise you. This comes out of previous year's exam papers, guys. They love this. They love this. So, ladies and gents, now we look at the next one. I love these kind of ones. Tan 188 times by sine 376 all over cos of 344. Step 1, get everything between 0 and 360. So this one I'm going to subtract 360. And I'm too lazy to write everything out, so I'm going to go sine of 16. And now this one is already between 0 and 360, but I want to get it between 0 and 90, so I'm going to skip to step 2 somewhere automatically. Third quadrant, so it's positive tan 8. This one is between 0 and 360, so let me get it between 0 and 90, so it is positive cos of 16 degrees. And I just quickly want to say this, ladies and gents. Understand, by what I just did, I already have 2 out of the 4 marks. Even if I couldn't do anything further, I still have 2 out of the 4 marks, which is much better than getting 0 out of the 4 marks. You've got to learn to score marks even if you don't know how to finish off the sum. So there's a lot of tricks in trigonometry specifically. Getting angles between 0 and 360, getting angles between 0 and 90, scores you half of the marks in almost all the sums. So please, grade 12s, I want everyone's eyes on me at this moment. If you are struggling, ladies and gents, to do trigonometry, make double sure that you can do reduction properly, as well as being able to get your angles as close to 0 and 90 as possible. Because you guys lose more than half of your marks by silly sign errors, silly identity mistakes. And the problem is, if you've done that one mistake, a lot of times your sum will not work out in the end. One sign mistake, and your left is not going to be right the same as your right, which means you might lose 2 or 3 marks even. So be careful. Ladies and gents, let's finish this one off. I don't want tan of 8. I want sines and causes. So what am I going to do? Tan of 8 is sine 8. So I'm going to do some funky magic. I'm going to put the sine 8 at the top and the cos 8 at the bottom. Because it's multiplication, it doesn't matter. And then I've got a sine 16 at the top and a cos 16 at the bottom. What? I have m at the top. And I have p at the bottom. Yes, sir. Okay, good question. Okay. Okay. Sir, you have a very valid question because quite a few of you guys, I know, wrote it like this. Sine of 8 degrees over cos of 8 degrees It seems like I know how your brain works. I don't know how I do that. Okay. But sir, if I take something times by something over something, it means the same as saying sine of 8 degrees over cos of 8 times by sine of 16 over cos of 16 because there's only times and divides. Now I can show you how this works by using just pure maths. If I go 4 over 3 times by 6 over 8, 3 goes into 6 twice. 4 times. Now you guys are like, wait, let me get my calculator. 2 times by 6 is? Okay, 2 times by, so 4 times by 6, sorry. 3 goes into 6 twice. 4 times 2 is? 8. Divided by 8 is? 1. Okay, now what about 4 times 6 over 3 times 8? Drop the mic. Okay? What allows me to do this, sir, is there's only times and divides. If there was pluses and minuses, I'm not allowed to do that. But because there's only multiplication and division, I am allowed to do that. Okay? So must we know all of these tricks? Preferably, yes. Remember, guys, what I said when you guys started here on Monday. I said, maths is the subject with the most amount of studying. Because this is a trick you actually got taught, most probably, between grade 6 and grade 9. You should have been taught this. I'm talking about the times and divides. Not the sines and the causes, but the times and divides. And the biggest issue that I found with matric learners, it's not the matric work that trips you guys up. It's the stuff that comes before that. So ladies and gents, what we are going to do from here on is I'm going to give you guys a lovely Lovely, next question. Now this question, I want you guys, the question reads, if tan of alpha is equal to -3 and b is x comma 6, determine the length of OB, but I'm going to make it interesting. You are not allowed to determine the value of alpha in the first step. You are not allowed to determine the value of alpha in the length of OB. I want you to do it without determining a value for alpha. And then the second question is, I want the length of C by any way you can do it. Any way. You can determine alpha in that one, I don't care. So in the length of OB, I don't want you to get alpha. I want you to use your understanding of trigonometry or any other mathematics. There's so many varieties in this question, that's why I love it. Those of you guys aiming for 90s and above, try and do this for me in 2 different ways. Because there is about 4 or 5 different ways of doing this sum. Ladies and gents, go for it. Fantastic. Love it. I would like to see trigonometry as well. I would like, it's not, listen carefully. It's not that I'm saying you shouldn't do analytical, but I want you guys to try and solve it by using trig as well. Because remember, you've got to stretch yourself to be able to do trig with us. Okay. I'm just going to put it out there. As I said, one of the ladies here asked me, but sir, I got like 1-2 ways. Guys, I'm not joking when I say there is literally 5 different ways. When we mark this, there might even be more, but we found 5 different ways, and it wasn't 5 ways that I thought out. It was 5 ways that my students did this. Okay? So, if you could only do 1, maybe 2, that's fantastic. If you can find all the ways, that's even better. Now, ladies and gents, what I'm going to look at now is I'm going to look at basically 2 ways. And I'm going to look at, first of all, guys, I'm going to start by looking at the definition of tan alpha. Now, the question is, what is the definition of tan alpha? It is the relationship between the opposite and the adjacent side. So if I tell you that tan of alpha is -3, well, that's -3 over 1. So in other words, the ratio between the y value and the x value has to be -3 to 1. But now, I give you this coordinate to be x, 6. So I'm telling you the y value is 6 units, and the x value, I don't know. So if I tell you that that is 6, well, that has to be -2. Because the ratio has to be -3. So therefore, x is -2. And there I've determined the x value for b. Now some of you might go and say, so am I supposed to know that? I asked a similar question for my grade 10s in this June exam. I'm going to start marking those tests very soon. I'm hoping that some of them at least got it right. But it's simply a ratio. So therefore, I can go and do Pythagoras and say OB is the root of 6 squared plus -2 squared. So this is the root of 40, or 2 root 10. That is the one way. What is the other way? Couldn't you determine an equation for OB? Okay, no, don't go. Sunshine, isn't this the gradient? Oh, I have the gradient of OB, so it means OB has the equation y equal to -3x, and it passes through 0. So the c value is 0. I know that the y value is 6. So if I sub it in, x is -2. That's another way. Or I could have gone, tan alpha is the gradient, and go, but the gradient is change in y over change in x. Wow. I would not have thought about that, sir. Okay. Stop heckling the poor person that's an hour late. Okay. Now, ladies and gents, that means this is 2 root 10. Now I draw another line here that's perpendicular to that line, and I ask you for this coordinate, which is OC, and therefore, now again, I have many ways of determining C's coordinates. I think most of you guys would have gone towards analytical. Because I have this one's gradient, which is negative a third, this one's gradient has to be 3. Why? Because their product must give me negative 1. And then you get the y-intercept of that line. So you can go and get the coordinate of that. Was there another way? Yes. You can get that little angle there between the y-axis and OB and work in that triangle to get the length, and the answer is 20 over 3 or 6,6 recurring. Say again? Which one? Oh, sorry, I apologize. This must be negative 3. So this gradient, my apologies, is a third. Thank you for correcting me. I do make mistakes. I know you guys are not used to hearing that from a maths teacher, but thank you for correcting me. Ladies and gents, we are going to move on to proving identities and solving equations. So what I'm going to do now is I'm going to give you guys 10 minutes to please, number one, prove the identity that is displayed on the projector, and then as well to solve that specific equation. So you've got 10 minutes, go for it. let's quickly have a look at this, at these two sums. Now, I want to say this, and I'm very honest when I say this, that a lot of you guys, unfortunately, lose a lot of silly marks by the way you write things out. I'm being very honest with you. You lose a lot of marks by your notation. Not that you guys don't know what's going on, but you just throw marks into the proverbial water. So ladies and gents, if I look at a sum like this one specifically, I would always start, again, I would start on one side and try and get to the other side. But please listen to me carefully, grade 12s. You do not just have to work on one side. You are allowed to work left, right, separate from each other, change on both sides, and get them equal. You are allowed to change both sides. Don't forget it. So if you have a tan left and a tan right, change both of them. You are allowed to do that. I know most of your teachers don't. They start one side, right, sunshine. They manipulate the living daylights out of that thing. Eventually they get to the end and they go, look how easy. And then you guys go, no, I would never. So I advise you work on both sides if need be. So if I look at this left-hand side, I would change sine 2a into 2 sine a cos a. Why would I do that? Look at where I'm going. I don't want the 2a in my answer. I want just an a, so the only way I can do that is by changing it. Now I'm going to change the tan a as well into sine a over cos a, and then minus 2. So now, that cos and that cos divides away, leaving me with 2 sine squared a minus 2. Okay, say again. I wouldn't. Okay, now ladies and gents. Okay, I'm going to do this sum in 2 ways to show you guys what I did. Number one, I would not factorize at all because look at where I want to go. I want to have only causes in there, right? So I'm going to change my sine squared into 1 minus cos squared. Because I look at where I want to go. I don't just all willy-nilly go and do this. I look at where I want to go, and there's no signs in there. So the first method I'm going to do is I'm going to change this to the sine squared into 1 minus cos squared a minus 2. It's not the only way, but it's for me a nice way. Because 2 minus 2, 0. Leaving me with negative 2 cos squared a, which is my right-hand side. Therefore, left-hand side is equal to right-hand side. But what is the second method if I stop there? The second method, ladies and gents, is why don't I change the right-hand side? I'm going to change the right-hand side, the cos squared a, into 1 minus sine squared a. Why would I do that? Because now I'm going to try and get the right-hand side the same as the left. So this gives me negative 2 plus 2 sine squared. But that's exactly that. So therefore, left-hand side is equal to right-hand side. I'm doing this method so you guys see I could both manipulate left or right or both, depending on the situation. Okay. Now we get to a lovely question. Question B. Hence or otherwise, determine the values of A for which sine 2A is equal or times by tan A minus 2 is equal to negative 1. So again, what does that expression on the left have to do with that top expression? Why am I thinking that? Because they use the word hence. They use the word hence, and therefore I'm going to try and use what I started at the top with what I have at the bottom. So how does this relate to that top? So, and hopefully you see that I proved the left-hand side equal to negative 2 cos squared A. But now this must be equal to negative 1 because of the identity that I proved. Now this is quite simple, that cos squared A must be 1 over 2 if I divide the negative 2 away. Now quite a few of you, not going to name names, went and did this. Quite a few of you went and did that. And then you called me and you went, "Sir, am I right?" And what was my response? Nope. So hashtag sorry, not sorry. Close but no cigar. What makes it wrong? What makes it wrong? Ladies and gents, do not forget the basic algebra that if I put in my own square root, there's both a positive and a negative answer. So in other words, this is going to change, giving me cos A equal to 1 over root 2, or cos A equal to negative 1 over root 2. And here comes the not so nice part, sir. When you go and write NBT exams, I'm allowed to give you this question without use of a calculator. And now you might go, as I see the shake of the head, might go, Okay, ladies and gents, and here comes the even worse part that I said earlier, remember? In your first year at varsity, no calculator in calculus. That is the not so nice part. But for this, you've got to know that you've got a special angle that is 1 root 2, which is how many degrees? So in other words, A, where is cos positive? In the first and the fourth. So I could have 45 degrees plus k times 360. Or I could have 315 plus k times 360. Or where's A negative? In the second quadrant, so 135 plus k times 360. Or A is 225 plus k times 360 degrees. And what did I forget? K is an element of Z. Now, ladies and gents, I want to very emphatically say this. If you got taught by your teacher that whole thing of the rules, if I've got sine of x equal to something, then there's a rule that applies. If there's cos, it's plus minus r cos. And tan has its own rule. Be careful of that rule, because in that rule, there's no real space for without use of a calculator. Because it does not require you to, how do you know negative 1 over root 2? That's where the problem with that formula comes in. If you got taught that way and you would like to know how to do this without a calculator, okay, feel free to stay behind. Let's make it for 10 minutes after the class today. And I'll gladly help you with how do I do this without a calculator. Okay? It might just save your bacon when you are doing the NBTs. Now, ladies and gents, I just quickly want to get a specific sum for you guys that I did with a grade 11s yesterday. Now, this specific sum is a bit of a different take on proving identities. Okay, sorry for that, ladies and gents. Okay, that was just a loose connection. This specific question, guys, comes out of, I think, an old exam that I set up. Now, of course, there was a first part of this question which said, prove the identity. It said, prove left equal right. Guys, I'm not going to ask you guys to do that. You can do that if you want to. But what I want to look at is this specific question, hence or otherwise, prove that there's no possible solutions for the equation tan theta minus cos theta over 1 minus sine theta equal to 0.3. I want you guys to answer this question for me, again, by looking at the given identity. Forget about this stuff about the monkeys and the mountains for now. Just please prove that there's no solution for that. I'm going to give you guys 5 minutes. Please, ladies and gents, prove that there's no possible solutions. Okay, I want everyone's eyes in the front. I want to say this, guys. Get used to, listen carefully, get used to these kind of questions, because you can't just plug it in a calculator, get an answer. You might try, but you must first do a lot of maths before you can actually use your calculator. So now the thing is, ladies and gents, when I look at this question, and one of the ladies here asked me, "Sir, but what would you consider to be the monkey and what would be the mountains?" The monkey is trying to get a value for theta. Remember what I said, I think it was on Monday or Tuesday. I said to you guys, if you ask me, prove there's no solutions, prove there's no roots, prove that this can't ever happen, you assume it will happen. So I'm going to assume theta will have a solution. So there is my monkey. Try to get a value for theta. And then disprove what I'm trying to do. Okay. So if I look at this one, my mountains would be, how does this relate to here? Well, for me, the easiest way of thinking about it is I know that I've got tan theta equal to something. Tan theta is equal to this whole thing at the top. So I am going to sub that into tan theta. Okay, now ladies and gents, look at the magic. The magic. Because cos theta over 1 minus sine theta minus cos theta over 1 minus sine theta is 0. So what is my answer? Negative 1 over cos theta equal to 0,3. Now I've solved the one mountain. Now, how do I solve a normal trig equation? Well, I would like to first of all get cos theta at the top, or let's actually divide by the negative. So I've got 1 over cos theta is negative. I don't want to work with 0,3. I'm going to work with 3 over 10. So, how do I get cos theta at the top? I reciprocate. So I'm going to flip it. And my answer is negative 10 over 3, or negative 3,3 recurring. Now, quite a few of you guys then came and said, but now what? Why, sir, when I plug it in my calculator and I try to get theta, the answer is undefined? This gent here, Seth, he had a very smart explanation. But what he said was, think about the relationship of cos theta. Guys, cos theta is hypotenuse over, or it's adjacent over hypotenuse. Can the adjacent be longer than the hypotenuse? No. It can't happen. So 10 over 3 cannot be, no matter which universe you look at. Okay? So, but what I like to do is a lot more practical approach and look at the cos theta graph. What is the highest value that it can become? The lowest y value? Will it ever go to negative 3.3 recurring? So it cannot have a solution. Now, how do I explain this to the examiner? I just go, therefore there's no solution. Guys, because the thing is, ladies and gents, you are supposed to know that cos of theta will always lie between -1 and 1. You're supposed to know that from grade 10 already. Now some of you guys are going, but sir, that's a long time ago. Remember that. That's again why trig and maths has so much study work. Because you've got to know your grade 10 and 11 work off by heart. Now, ladies and gents, I am going to give you guys a sum to solve for me however you want to. And I'm going to rattle your cage with this sum a little bit. But it's okay. You guys can take it. Please determine for me the general solutions for this equation. 1 minus cos 2 theta equal to sine 2 theta. I'm going to give you guys, let's make it 4 minutes because we're running out of time. Believe it or not. Okay, so I'm going to give you 4 minutes to please do that one for me. Solve for theta. I'm a bit quick on you guys. Some of you guys are not done yet, and that's fine. But ladies and gents, when we have a look at this specific sum, I know the one thing that freaks you guys out is what? The cos 2 theta, right? It kind of freaks some of you guys out because how do I know which identity must I change it into? And some of you guys are a bit trigger happy. In other words, the moment I see a 1, I make it sine squared plus cos squared. Please don't do that. You're making the sum much bigger than it ought to be. It's not that you won't get to the right answer, but you're going to Cape Town via Durban. And the problem is sometimes you might get lost along the way and you never get to Cape Town at all. Okay, so ladies and gents, what do? The problem I'm sitting with is not the cos 2 theta and the sine 2 theta. The problem is that that 1 doesn't fit anything else. So what am I going to do? I'm going to try and get only thetas in, because maybe then I could handle that 1. So I'm going to leave the 1 as is, and I'm going to change the 1 that I know has to change. And now here comes the dirty little school trick. Ladies and gents, you only change the cos if you know where you are going. Now in this case, usually, sir, I would go and change the cos into sine and cos because of the right-hand side, usually. But in this case, I'm going to change it into 1 minus 2 sine squared theta so that the 1 and the 1 can cancel out. So number 1 is I would go and look, where do I want to go? Or can't I cancel out some numbers? Well, in this case I can, because 1 minus 1 is 0. Minus and a minus is a plus. 2 sine squared theta is equal to 2 sine theta cos theta. Now, the question is, Sunshine, what kind of an equation is this? Forget about now the signs. What kind of an equation is this? It is a quadratic equation. How do I solve a quadratic equation? I get it equal to 0. Ooh-wee. Sir, I did not think about that. Once I have equal to 0, how do I solve a quadratic equation? I factorize. So I'm going to take out 2 sine theta common, which leaves me with sine theta minus cos theta equal to 0, which gives me 2 sine theta equal to 0, or just sine theta equal to 0, and sine theta equal to cos theta. Okay. Now the question is, how do I solve that further? Please somebody tell me. Say again. You can try cofunctions or divide by cos. Because this gives me tan theta equal to. Okay, now. Okay, ladies and gents, everyone quickly pay attention. What I'm going to share with you guys now, remember when I wrote the sum on the board, I said, I am going to rattle your cage a little bit. Quite a few of you guys have, when you got to this point, did this. Okay? Now, ladies and gentlemen, I want you guys to pay attention, because this might give you or save you a lot of marks in the exam. Those of you that did that can attest. I said to you, got everything right to that point, and then 0 for the rest. But now my question to you guys that I want to pose is, why, when I divide by a sine theta, a trig identity or trig function here, I give you 0 for the rest, but here I'm allowed to divide by a trig identity or trig function? Why, in the one sense, it is wrong, your teacher stops marking, but in the next one, it's 100% right. Okay, and now, please do not ever respond with the answer of, because my teacher said so. Because I know, all of you guys get up to this point, and instinctively you divide by cos theta. Why? Because your teacher said so. Am I right, sir? Okay? You do that, why? Because your teacher said so. And the problem is then you guys go and do it up in a sum and you get naught, and then you are angry at your teacher. Pretty much, yes. The question is, what's the difference? Okay, ladies and yes. Undefined. Why undefined? Okay. Why is that undefined? Where's undefined? I don't see undefined. Okay, ladies and gents. Let me quickly share this with you guys. You're very close. The thing is, guys, look at this. Sine theta equal to 0 is a possible solution. If I make sine theta 0 on both sides, my left is equal to my right. So in other words, if I divide by sine theta, I could actually be dividing by, am I allowed to divide by 0? Now the question is, what about this? What makes this different? Guys, look at the graph of sine theta and cos theta. There's the basic graph of sine theta and cos theta, or sine theta and there's cos theta. Remember, this happens when two graphs cross each other. Is it a possible solution that cos theta could be 0? No, because here and here, neither of my two functions are 0, so it's not a possibility. That's why we're allowed to divide by cos there, because cos theta equals 0 is not a possible solution for the equation. You've got to be careful. And now here comes the very nasty thing. All of you guys are looking at leaving matric this year, hopefully. And all of you guys are looking at going into a degree. And that includes the guys at home, hopefully. Ladies and gents, you've got to be careful. If you rock up at a lecture and the lecturer asks you, but why are you allowed to do this? And you tell that lecturer, because my teacher said so. You know what he's going to respond? Ach, shame. You're not allowed to do that if you are not able to tell me why. Yes, that hoekom. Ladies and gents, you've got to learn to think for yourself, because that's going to make the difference between whether you not just succeed at matric, but whether you succeed at university. Guys, there's a lot of people who do well in matric that struggle at varsity. Now, ladies and gents, your homework for today. Okay. Ladies and gents, look at me carefully. Last 2 minutes of the class. Your homework for today is I would like you guys to try this sum for me, these two. Number one, proving the top identity. And number two, here comes the beautiful one. Determine the maximum value of that. Okay? That's going to be your homework that I would like to go through with you guys the first 5 minutes tomorrow morning when I see you guys at 8 o'clock sharp. So, ladies and gents, that's all she wrote from my side. Thank you guys for tuning in via live streaming. Thank you guys for being such an amazing audience. See you guys 8 o'clock tomorrow morning. Cheers, guys.